So somewhere in your notes, just write, we have a problem. I called it problem 9b because we already had problem 9s. This is 9 part 2, I guess. We have zeros of -6, 4i, 3 with a multiplicity of 2, and 0. And we're mainly focusing on the beginning today is what this word multiplicity means. But let's talk about, before we get to that, let's talk about what we know about our zeros. So I have a zero of -6, 4i, 3, and 0. Are there any other zeros that I also know that I have?
Positive 4i or negative 4i. Sorry.
I have to have both a positive and a negative 4i. So I really actually have 5 zeros for this problem. So if I have 5 zeros, then I have to now write my factors. So let's start with the first one, -6. If my 0 is -6, what are my factors? X plus 6. Okay. My next factor was 4i. Sorry, my next 0 was 4i. So what's that factor? X minus 4i. Okay, then I had a factor of a 0 of -4i, so my factor would be x plus 4i. And then I had a factor of a 0 of 3 with this whole multiplicity of 2 thing. So let's start with, if it's a 0 of 3, then what's the factor? X minus 3. The multiplicity of 2 means that it is squared. So nothing complicated, just like we didn't take the time to talk about that yesterday. So if something has a multiplicity, it just means it has an exponent attached to it. It could have a multiplicity of 2, of 3, of 4, of 5, of 6, 7. It doesn't really matter. Just whatever that multiplicity is, that's the exponent. So now talk to me then, if it's a multiplicity of 2, if it's an exponent of 2, what does that tell you about the graph when it gets to 3? It's tangent. It's going to be parabolic in shape at that point. It is. So what if it said that the multiplicity was 3? What would that mean about the graph? It would cross because it's an odd multiplicity. Okay? And then if my last factor is 0, or my last root, I'm sorry, or 0 is 0, my last x-intercept, what does that factor look like? It's just x. And a lot of people try and write it as x minus 0 or x plus 0. Okay, that's fine. But what's x minus 0? It's just x. Okay, it's okay. Just x. So we can write x minus 0, or you can just write x. It's the same thing. So that would be my complete factorization of this problem. Now, if I wanted you, and I'm not going to ask you to do this, but if I wanted you to multiply it back out, if I said, okay, now you've got all this, multiply it out, where should you start? Okay, I should separate the x minus 3 into 2. That would be helpful. And I need to multiply my 4i's together. Anytime you have imaginary numbers and you have or square roots, you've got to multiply the imaginary numbers together and the square roots together. Because the whole purpose of these is that essentially this is like a factored form of difference of perfect squares. Because, like, think about difference of perfect squares, like writing a totally random problem up here, but it'll relate in a second. Like, if I said factor x squared minus 9, that would be x plus 3 and x minus 3. Well, that's essentially what you have here, x plus 4i, x minus 4i. So these are going to end up canceling each other out, the middle parts, and you're just going to be left with the foil, the first and the last part of the foil. The oi part disappears. They cancel each other out. So... but if you don't start with that, if you start with multiplying, and I saw this a lot yesterday, people were trying to multiply x plus 6 times x minus 4i, and you end up with some awful things in there. So always multiply the x minus 4i, x plus 4i together first, so that all the i's go away, and then do the rest of your multiplication. Alright, so you don't have to write this down, but you can take a picture of it in a second. Ways to factor. We've learned a lot of different ways we can factor.
Yes.
What are some of them that we've learned?
The
AC method. Okay. So AC method works on what kind of problems? Trinomials. Does it work all the time or some of the time?
Some of the
Okay. What else?
Sure.
What is the AC method? It's where you have like 2x squared plus 7x plus 5, and you multiply A times C. Okay. Ah, completing the square. Don't worry, we don't have to do it today.
Quadratic function.
Okay, quadratic formula. We're going to put that on our next screen, okay? Because we're going to do a different screen in a second, so we'll put that on the next one, okay? What else? What are some other ways we can factor? Difference of perfect squares.
Difference of cubes. Sum of cubes.
Okay, hold on. So difference of perfect squares. And then sum and difference of cubes. And remember, sum and difference of cubes, I told you, you would never have to memorize those formulas. I would always provide them for you. So that is true. Okay? What else? Grouping. Ah, when does grouping work?
You have 4.
4 terms. Okay, so grouping. That needs to be an O, not an A. Okay, grouping. What about long division? Not fun, but doesn't it technically factor?
Yeah.
Okay. And then if long division works, what else works that y'all did like?
Substitution. No, that's not it. No.
Synthetic division. That's the other one. Start with an S, same thing. Substitution, synthetic. Pretty much. Synthetic division, which we liked synthetic division. Well, I mean, as much as you can like division, you liked synthetic division. We'll say that. No, that's not it. I'll tell you when we're done. We can find our possible zeros.
Ew.
That's what we did at 8.1, where we found all the possible zeros and then figured out which ones actually were zeros. Okay, so we can find our possible zeros, our possible, let me add that in there, our possible rational zeros.
Fractional.
Yes, because rationals are fractional. Could we technically graph the function? Because if we graph it, then we can find our zeros. Again, that works for rational zeros. It doesn't work for anything else. Okay, so this is a pretty comprehensive list. We'll think we're good for now. So you can take a picture of this if you want to. Sorry, last one we forgot was GCF. Ways we solve polynomials. Okay, how do we solve polynomials?
Pythagoras. Nose goes.
No.
I don't know what I'm talking about. I think so. We solve polynomials. We math. We do quadratic formula.
Yeah. Quadratic formula, that's a real answer there. Okay. Quadratic formula. How else can we find our solutions or our x-intercepts? What could we do?
I can't remember what it's called. It's like vertex.
We could do completing the square, which is vertex form. Don't worry, we're not going to do that. I'm just saying we can.
Wait, I totally forgot how to do that.
That's okay.
Yeah.
We're not going to go over it. It's fine. You can complete the square. You can do what's called the zero product property.
Have we learned that?
Yes.
Can you do synthetic division?
The zero product property says that you graph it. We could graph it and find our solutions, find our x-intercepts. Long division will find our factors. It won't find our solutions. Once we have our factors, then we set them equal to 0 and solve. We can also do, hold on, I had it and then it went away. Where did it go? We can take the square root. And I think that's pretty much all. Okay, so you can take a picture of that one. 427, problem A. Oh, I forgot another thing.
Oh my gosh.
Another way to factor. I forgot one. GCFs.
Oh,
yeah, I didn't hear you. I'm sorry. Okay, so talk to me about this problem. How do I factor it?
Take it out.
I can factor out an x squared because that's the GCF. So if I factor out the x squared, then I'm left with x plus 7. So if I now ask you, it's factored. So if I said, hey, solve this, tell me what my x-intercepts are. Tell me what my zeros are.
Tangent to 0, and you're going to cross a negative 7.
I'm going to get a 0 of 0. And I'm going to get a 0 of negative 7. What are you guys saying is going to happen at 0?
Tangent.
It's going to be tangent, or we could say that it has a multiplicity. Multiplicity.
I had such a hard time saying that word yesterday.
Of 2.
Multiplicity?
I can say the word, I can't spell the word. But I think saying it's more important, because how often do you spell the word multiplicity, except right now? Okay, so it has 2 zeros. Well, technically it has 3. When it means it's a multiplicity, that really means if I were to expand this all out, like think about this, x squared. If I were to expand that out, how many x's is that? 2. So that means if I set each of my factors equal to 0, there was twice that I would get 0. That's what that means to have a multiplicity of 2. Okay, so we solved that problem. We found our solutions. Could we graph it now?
Yeah.
I'm not going to make you do that, but could we? Yeah. Okay. All right, so look at the next problem. X cubed minus 64. It's a sum and a difference of cubes. Okay, so I'm going to give you the formulas for those. I told you I would always give you the formulas for those. So this is a difference of cubes. We know that because there's a minus sign in there. So difference of cubes says that a cubed, that's not an a cubed minus b cubed equals a minus b times a squared plus ab plus b squared.
Same, opposite, always positive.
Yes, same, opposite, always positive. This was from section 7.3 when we did factoring more in depth. All right. What is a in this problem then?
1.
1x. And what is b? No. It'd be 4. Because 4 times 4 times 4 is 64. Because remember, that part is b cubed. So 64 is 4 cubed. So they've already started filling in part of this for us. They were kind of nice. So here we know we're going to have, it says a minus b. So we're going to have x and 4 there. So what sign's going to go in the middle there? Subtraction. It's the same sign. Okay, then we have x squared. And what goes in this box here? A times b, so that would be 1x times 4, which would be 4x. Okay, what about this last box here? What's going to go there? 16. How do you know it's 16? Because it's 4 squared. It's the b squared part. So I get 16 there. Okay, can I factor this anymore? Yes, no, maybe. Okay, could I factor this first parentheses? No, for sure not. It's an always good indicator that you cannot factor anymore if the degree is 1. That's a good indicator that you're done factoring for that part, for sure. Okay? Can you factor this? What ways could we factor this? What would we have to do? AC method. Okay, but one of the things I told you when we did sum and difference of cubes is that this second parentheses would never factor. So what we would do is normally we would try it and see if it worked, but I'm telling you it's not going to work, okay? So I'm just saving us some time in the long run. So if I now have my factorization, I said, okay, solve. What are my solutions? Let's talk about this one, x minus 4. X equals 4. And that comes from, you were asking earlier, what the zero product property was. The zero product property says if I have two things that I'm multiplying together and they equal 0, then one of those two things must equal 0. We do this all the time, we just don't say that's what we're doing. Like we did that on the previous problem when you told me that my zeros were 0 and 7 because it was the opposite of negative 7. So for this first one, x minus 4, what's my 0? 4. Okay, I got one of them. All right, for the second one, we can't factor it, but we have to solve this. So think about our ways that we solve. We can use the quadratic formula. Yay! See, I told you this was so exciting, isn't it? I don't think there's a Jackson the Space Dog video about this, sorry. So x equals negative b plus or minus the square root.
B square minus
4ac all over 2a. I know. You'll be fine. And we plug in what we know. So if we plug in what we know, it says negative b, so what are we going to put there? Negative 4 plus or minus the square root of b squared. What's b in this problem? 4. So 4 squared. That looks like a weird 2. That looks like a weird 2 still. There we go. 4 squared minus 4 times a times c. Yep. All over 2 times 1. Okay. So when we go to work this out, which part do we do first? Inside the square root. And what is the name of that inside the square root?
discriminant.
The discriminant, yeah. It's not the crim, it's the discriminant. Close though. The criminant, yes, the criminant. Okay, so we work out the discriminant first. What does that give us? Not the square root part, just the part underneath it. 4 squared minus 4 times 1 times 16. Negative 48. So now my problem says negative 4 plus or minus the square root of 48 divided by 2. Oh, sorry, negative. You're right. I just didn't write that. I apologize. So negative 4 plus or minus the square root of negative 48 divided by 2. Can I take the square root of negative 48?
No.
So I know now what it's going to be. An imaginary number. And if I have an imaginary number, how many roots am I going to come up with? 2. Because imaginary numbers always come in pairs. So we're going to have 2. A positive and a negative. Okay, so how do I simplify that and make it look prettier? I can only reduce, because several of you are saying I want to divide the 4 by the 2. I heard that from a couple different people. I can only do that if I can reduce the number that's here as well. So think about square root of negative 48. Okay, so what did you do to get that?
You have to multiply, or you have to find one of the squares that multiply by together to get.
Okay, you need your factors of 48. So you're on the right track, but that's not the one we're going to go with. We're going to talk about why. But you're on the right track. So tell me the things that multiply to give me 48.
2 and 24.
Okay, 1 times 48, 2 and 24,
3 and
16, 12, and 6 and 8. Okay, which of those numbers that we just listed are perfect squares?
4, 16.
And 1. So out of 1, 4, and 16, which of those is the biggest? So we're going to use 3 and 16 to simplify this. So I'm going to zoom back in. So I'm going to rewrite this as negative 4 plus or minus the square root, and I'm going to write on the inside negative 3 times 16 divided by 2. Which of those can I take the square root of? 16. What is the square root of 16? So I get negative 4 plus or minus 4. And what happens if I have a negative inside? What does that mean? I square root 3 all over 2. Now can I reduce? Why? Don't worry about that because I'm reducing the part that's attached to it. I look at the 4, and the 2. So can I divide all of those numbers by something? By what? 2. So what's negative 4 divided by 2? So negative 2 plus or minus 4 divided by 2 is 2i square root 3. How many roots is that? 2. A positive and a negative. So I had those 2 zeros, I had those 2 roots, I had those 2 x-intercepts, those 2 solutions. What was my other one that we came up with just a second ago for this problem? 4? Okay. There we go. So there's all of my solutions to this problem. 428. We got a problem at the top here. Okay, so we're going to start with this problem. All right, so how do I factor this one?
Group.
How do you know it's grouping?
Because it's 4.
Okay, should we do something else first?
You can take out an X.
Yes, there is a GCF here. And that GCF is x. So if I take out the GCF of x, then I'm left with x cubed plus 3x squared minus 4x minus 12. And now I still have 4 terms, so that's good. But now that I have 4 terms, I can actually group and factor. So I'm going to group and group. Okay, so talking about that first grouping, x cubed plus 3x squared. X cubed, x squared, x squared. If I factor that out, I'm left with x plus 3. Okay. What about negative 4x minus 12?
4.
Negative 4, and then I'm left with x plus 3. And I know I did it right because,
They're the same.
yes, as long as my parentheses are the same, I know I have factored correctly. So then if I rewrite this, it'd be x squared minus 4 times x plus 3. And don't forget our GCF that we brought down, which was x. Is there anything else I can do to that problem?
Factor the X squared minus 4.
It's a difference of perfect squares. X squared minus 4 factors.
X minus 2 and X plus 2.
X minus 2. It's okay. X plus 2. I still have x, and I still have x plus 3. So I have 4 factors, and that means I have 4 zeros, 4 x-intercepts, 4 solutions. What's my first solution?
0.
0. Okay. What's the second one?
2.
What's the third one?
-2.
And the last one?
-3.
Okay, look back at your original problem. What was the degree of the problem?
4.
So that meant we were supposed to have 4, and we did, so that's good.
That was pretty easy.
Okay, yeah, that one was okay. All right, so same page. Page, 428. Problem D says x to the 4th minus 16. So the question is, can we factor that one?
Yes.
Why?
Because you can't do that if it's positive, right?
Correct. If it was positive, we could not. But if it's negative, we can. This is a difference of perfect squares because x to the 4th is a perfect square. X squared times x squared. 16 is a perfect square, 4 times 4. So it factors well. But wait, there's more.
You can do it again.
Which one factors again? And again, you cannot factor it if it has a plus sign. That's important to remember. So x squared minus 4, how does that one factor?
It factors nicely.
Yeah. X plus 2, x minus 2, and then x squared plus 4. Okay, and I can't factor x squared plus 4. That one doesn't factor. So I've got a couple options. Well, I need to solve this now because we factored as much as it can be factored. I need to solve it. So starting with the first one, x plus 2. That one's easy. What would be the solution for that one? Negative 2. Okay. What about for the second one? Positive 2. All right, but I can't do that with this last one. So remember what I'm doing with the zero product property says if I set this equal to 0, I can solve it to find the solutions. So what could I do with x squared plus 4? Other way around.
Subtract 4 and then unsquare.
Yes, I could subtract 4 and unsquare. Could I do quadratic formula on that technically?
Yes.
What would b in that problem be?
0.
0, because there's no zeros there. Okay, my suggestion, because I think it's the easiest, is to just solve it. Minus 4 from both sides. And I get x squared equals negative 4. How do I unsquare? Square root it. So if I square root negative 4,
But,
2i.
um,
Yeah.
You have a positive and a negative 2i. So my 4 solutions are x minus 2, x equals negative 2, positive 2, and positive and negative 2i. Okay, this one's on the top of page 429. All right, what do you got? Can we group?
No.
Why not? 5, and we can only group with 4. Okay, so think back to that list we made. We can find our rational zeros. How do I find my possible rational zeros? Okay. All right, so the possible zeros are the factors of 8 divided by factors of 1. Okay. So what are my factors of 8? 1, 2, 4, and 8. They set it up really weird, and I don't like how they set it up.
I still don't understand
You don't understand what?
how they set it
Oh,
up.
I have no idea what they're doing.
I'll get it.
And then factors of 1. They're doing the same thing. They just write it weird, and I don't like how they write it. I don't understand what they're doing. Okay, so, this part's easy. So, okay, now tell me what my actual, possible zeros are. 1, negative 1. 2, negative 2. 4, negative 4, and 8, and negative 8. And I got those because I divided the numbers on top by 1. Okay, so let's figure out what those numbers are, what if they give us 0. All right, so plugging in these rational zeros, I now know what 2 of my zeros are. What are 2 of my zeros?
1 and negative 2.
Okay, but how many am I supposed to have total?
4.
So I've got to figure out how to get the others. So we're going to finish this problem tomorrow. Any thoughts on what we might be doing to finish this factorization? Thinking about our list, what we haven't gone over yet.
Add more numbers.
I can't add more numbers. These are my only possible numbers. We're not going to complete the square. They don't have a GCF.
Look at the book.
Synthetic division.